So in this lecture we will discuss what is a compiler. So compiler will convert your source program into target program or output. So here, so what is the source program? Source program is nothing but the thing which you are typing as C program or any other source program, and target program is nothing but a machine understandable code. Okay, so we will look more, we will see more what we can understand further about a compiler. So as I told, it converts your source program into target output, that is nothing but a machine understandable code. So before understanding everything about compilers, we need to understand what is meant by interpreter. So interpreter is nothing but it is also similar thing of compiler, but it has a small change. Okay, so what is that change? It also converts your source program, okay, source program into particular output. Okay, but what is the difference means it takes a user input. So the user input is also given as an interpreter, and the major change between compiler and interpreter is it translates, means it converts only one statement at a time, whereas the compiler, so compiler will take all the statements of a program together and it checks for some error correction, syntax analysis, semantic analysis, and it will produce a target machine code, whereas your interpreter will take source program and user input as only one statement at a time. Okay, so that is the difference between compiler and interpreter. So after that we will just see the introduction. So what are the cousins of a compiler? As you can see, cousins of compilers are nothing but preprocessor. So preprocessor, what is a preprocessor will do? Preprocessor will have a source program. Okay, so source program, that source program will be given to compilers. Okay, the compiler will convert the program into target assembly program. Then the assembler produces a gives your programs to loader. So what it does is it is converted as relocatable machine code. So in loader or linker editor, what it does, it just links to particular libraries. Okay, so finally the machine language code is produced. So we will see an example what is a preprocessor. So preprocessor is nothing but a shorthands. It has some macros. Okay, macros you will be using in codes. That is shorthands. Okay, that is the preprocessor, or we can say hey, header file .h file or like that. So that is a header file is also a file inclusion. And rational preprocessors are nothing but built-in macros. Okay, I can create my own code and I can convert it as a macros. Okay, that is also rational preprocessor. Then finally language extensions. So for example, extension of the language means in C language. So C language I can create some database, and that database can be given to input a particular code. Okay, so that is the extension of a language. So these are the examples of preprocessor. Then assembler. So what is an assembler? So just for an example, we have taken this code B is equal to A plus 2. So assembler will convert this code into assembly language. So you can see here move, what it does initially, move A comma R1. So what is R1? R1 is nothing but a register. Okay, register R1. 1 is nothing but a register 1. So this value A is moved to register 1, and we are adding that value 2 to register R1, means already I'm having a value here. So A can have some values like 3 like that, right? So 3 plus 2, then that value answer B 5 will be stored here. Okay, like that it produces a assembler. So finally loaders and link editors. So what is a loader? So loader, it is nothing but it loads. Okay, it is a relocatable machine code. So relocatable machine code, it loads performs the two functions. One, it is a relocatable machine codes with which alters the instructions and data into proper memory locations. Okay, so it assigns to proper memory locations. That is one important thing. Okay, memory, it assigns your code to proper memory locations. Next one is link register. So link registers, so we are having various number of programs. Okay, several files will be converted into make a single file. Okay, so it just link it allows several files of machine code into a single program. So that is the thing of cousins of a compiler. Okay. Then before understanding the compiler, so but how does a compiler works, you need to understand. So you need to see analysis and synthesis model of a compiler. So what does it mean? So the given source code, okay, we are having a source code, means my input. So that input is converted into two terms. One is a front end, another one is a back end. So front end, it does the analysis part, and back end, it does synthesis part. So front end to analysis, so it will come like this. So front end to intermediate code, and then intermediate code to synthesis, that is machine code. So it will be done like this. So this is the analysis of a compiler. So analysis of the compiler, the analysis part, the source program is converted into an intermediate code. Okay, so it is called a front end of a compiler. In synthesis part, it constructs the desired target code. Okay, it constructed desired targets code, and it is known as end of a compiler. So this is the analysis part and analysis and synthesis part of a compiler. Finally, we'll see phases of a compiler. Okay, phases of a compiler you can see. So source program, so the given source program is converted into following phases: lexical analysis, syntax analysis, semantic analysis, intermediate code generator, code optimization, code generation. So finally, we'll be getting a target code. Okay, so if you see, all these codes are connected to symbol table manager, and finally all these phases are connected to error handler. Okay, so we will see one by one what is this. So lexical analyzer, if you see, it is a stream of characters. So stream of inputs are converted into token name and attribute name. That is a lexical analysis. So whatever stream of characters we are giving, that are converted into token name. So what is a token name? For example, you can see here, position is equal to initial plus rate star 60. So this is the given statement. Okay, so the position is converted. See the symbol table. So symbol table which we saw previously, symbol table has a position of 1, and this initial is given as position of 2, and rate is given position of 3, like that. So it is given, this is a symbol table, it is marked like this. So then how to write this token name is, this is a first position now. So this is id 1. So you have to write like this, and then initial is equal to id 2 plus rate is id 3 star 60. So likewise, so this is the input. Okay, this is my input. So this input is converted as output like this. Okay, id 1, why it is 1, you know, this position is 1, and id 2 plus id 3 star 60. Okay, next we will see syntax analysis or parsing. So what is the input here? So I got this input here. Okay, so this is the output, but this is the next phase. This is the input here. So what it do, it will represent a tree like structure. Okay, tree like structure means, see, it is a parse tree generator. Okay, so parse tree generator will look like this. So parse tree generator, so each interior node of a syntax tree is represented as an operation, and the child node represents the arguments of the operation. So each interior node is a syntax tree is an operation. Okay, so it is an operation, and the child represents the arguments. So it is an operation and arguments. So what is this id 1? This is the operation is equal, and here the operation initial plus, so id 2 is plus. Okay, and here the star is the operation, and interior childs are represented like this. Next we can see semantic analysis. Semantic analysis is very simple. It is a type checking. So type checking means what? So here, for example, we can assume that the position, the variables position, initial, rate are floating point values, whereas the number 60 is an integer. So this the semantic analysis phase will convert this this integer 60 into float. So how it can be, it can written is just here a small change. Okay, so int to float, so the same parse tree only you have to write, and here you have to do only one small change, int to float of this value. Okay, the next phase is intermediate code generator. So intermediate code generator generates 3 address code. So why this phase means finally we need to produce a machine understandable code. So to make the things easy, so it should be it should produce an easy code which is a target machine understandable code. For that only we are going for this 3 address code. So 3 address code, what it does is this int to float is given here like this, int to float, and the t1, okay, it is represented as a some temporary variables t1, t2, t3, like that. T1, T2, T2 is ID3 star T1, so just we are going back reverse. Then T3 is equal to ID2 plus T2. Okay, so likewise it is given here, and finally ID1, the final line is ID1 is equal to T3. It is hidden in this video, just I'm writing here. So this is the 4th line, this is the first line, so just we are traversing like back like this. Okay, so likewise it is given. So finally the next phase, 5th phase, is code optimization. So optimization, what optimization will do? Optimization will produce the shortest code. Why the shortest code is needed? It will for less power consumption. Okay, so how it is converted here? The same thing only. So here T1 is equal to ID 3 star 60.0, means no need to give that line int to float. Instead it is already converted the value as a floating point value, and that is given as a temporary variable T1. And finally we are having one more variable ID1 is equal to ID2 plus T1. So optimizer produces a valid output, and it produces like this. So finally it is an assignment of registers. Okay, registers R1, R2 to the particular values, code generator. So code generator will produce the, means what is the work of code generator? So map an intermediate representation into target language. Okay, so target language, so the intermediate representation is translated into sequence of machine instructions. So these are nothing but sequence of machine instructions are given here. Here you can see this is for this input. Okay, so this for this input, these are the output. So load the floating point values ID3 in register R2, then multiply the values okay with the floating point value 60, and then load the value ID2 to register R1, and finally add the values and store the floating point values, okay, in register. Okay, so this is the code generation part. Okay, so finally we will see what is the role of symbol table management and error detection and reporting. So symbol table management, is used to record the variables which are used, okay, and the procedure name. So what are the variable name will be? So the variable name will be in form of storage, type and scope. The procedure names will be the arguments what we are using in the program, and what is the number of arguments, how many what is the type of each argument, and the return type. These things will be managed by your symbol table. So error detection and reporting means each and every phase, that is from the lexical analyzer, syntax, semantic analyzer, some errors if it is noting, means that errors will be handled in this phase. So that's all about introduction about compilers. Thank you.